Okay, so we are going into section 5.1 and 5.3. We are taking them together. But this section 4.1 is about our exponential function, which is still important in this session. All right. So there are two main types of interest rates. The first one is what we call the simple interest. In simple interest, we earn interest on the principal only. On the principal only. That means the interest always stays the same every year. The interest stays the same. So that is simple interest. Now the next interest is the compound one, which we earn interest on the principal and on the interest already earned in the previous years or periods. Okay, so that means the interest increases every time. This is more interesting, and this is what we are going to be using. This is more interesting because the interest is on the principal and on the already earned interest. So we are going to be dealing with this more. Okay. Okay, for example, if we invest 100 Rand at 10% per year at a simple interest, then the interest we will receive per year is as follows. In the first year, the interest will be 10 because we have the interest, the rate equals to 10%. So 10% is simply 10 over 100. If I find 10% of 100, that will be 10 over 100 multiplied by 100, and then I will be having equals to 10. So it's 10. For the second year, it will still be 10 because I'm taking interest on the principal, and here, this is the principal. This is the principal because I'm taking on the principal only. So it's still 10, it's still 10, it's still 10. Okay. But when it is compound interest, I'm taking interest on the principal. The first year will be 10. Now, if I'm taking for the second year, I will add the interest in the first year with the principal. That will become 100 plus 10, which is 110. Okay, so I'm going to take interest on this now. So it will be 10% multiplied by 110, which is this cancel this cancel this. So we see in the second year it's going to be 11 Rand. So we see the interest increases. Okay, so in the third year it will increase to this. In the fourth year it will increase to this. So we see that in compound interest, the interest increases every year, unlike the simple interest. So that's why this is the case we use in a practical session in life or in accounting and other field that uses interest. Okay. Now, the formula, in this module, you are going to come across a lot of formulas. Please, you need to know them because you use them always. Okay. So, in simple interest, we have the future value, the present value, the rate, and n is the year, as we listed here. So we can call this one equation 1. Let me call this one equation 1. In order to find the future value of a simple interest, you use this formula. But for a compound interest, you use this formula called equation 2. We use this formula. So now we see the difference. In simple interest, we are just multiplying the rate with the year. But in compound interest, we are finding the exponent, the power, using the year is the power. Okay, not just multiplying by the rate. Okay, so the total interest earned or paid will be the future value minus the present value will be the total interest earned or paid. All right? Now, this future value is also called accumulated value. Sometimes we refer to it as accumulated value and not the future value. Also, this principal is also called initial amount, or we call it present value. Later, we are going to be using this more. We are going to be using this term more. Is the present value. Okay, is the present value. All right, please take note. Let me call this equation 3. All right. Now, let's demonstrate that to see how the interest increases. In a simple interest, if we have our principal to be 6,000 and our end to be 8 years and our rate to be 8%, and we calculate the simple interest using equation 2 or equation 1 rather, using equation 1, using this equation 1, we are going to get that the future value is 9,840. That is the future value. And we can see the interest we got is 3,000 something, 3,000 plus. But if we use the same for compound interest, if we use the same for compound and we use the formula in equation 2, we get that the value is 11,000 something. And then the interest is 5,000. You see, the interest is higher than this one. Okay, so the interest is higher. The value, the future value we got when we invest into using 6,000 is higher than the one with simple interest. So that's why in reality, this is what we use. Okay. All right, so when we are compounding, sometimes we compound not only annually. If you look at the example here, the example is compounded annually. We don't compound only annually, we also compound maybe monthly, weekly, bi-monthly, and things like that. Okay, so when working with compound interest, the interest rate will always be written as 6% per year. This can change to anything, 8%, 9%, 9.5, whatever it is. But this is very important to us, compounded M times. So compounded M times. So you must always watch out for these ones because this will change the game. Okay, we must always watch out for that. Okay, so if we say compounded monthly, then that means M equals to 12. The one we did before, compounded annually, it means M equals to 1. Okay, so we're going to see that now. So, now, if we say compounded yearly, then M is 1. Compounded semi-annually, then M is 2. If we say compounded quarterly, then M is 4. Compounded monthly, then M is 12. Compounded weekly, then M is 52. Compounded daily, then M is 365. Okay, so please watch out for that because that is one of the key things when we are dealing with financial mathematics. Please watch out for that. All right, so when M equals to 1, that is compounded annually. Then we call that interest effective rate, or we call it annual percentage rate. So it's either called effective rate or annual percentage rate if M is 1. But if M is any other value apart from 1, then that is called a nominal rate. So, for example, if M is 12, it's called the nominal rate. If M is 52, it's called a nominal rate. Okay, so any other rate apart from annually, then that is a nominal rate. That is a nominal rate. Any other rate apart from annually, then that is a nominal rate. So our formula that we have in equation 1 and 2 can now change to this. no, equation 2 rather. Equation 2, this is our equation 2 before. This is our formula 2. Now we can now have another one we call formula 2b that take into consideration our compounded, our m, which is compounded. Okay, so now you see now from this, so this equation 2b is a general one to equation 2. Okay, this equation 2b is a general one to equation 2, so I write it again and I say s equals to 1 plus r over m mn. So now if m equals to 1, we are going to be getting, if m equals to 1, we are just going to be getting what we started with. It implies s equals to 1 plus r over 1, then n multiplied by 1, which is the same thing as p 1 plus r n. Okay, so we get our equation 2 back when m equals to 1. But this equation 2b is a general form, taking note of what m could be if m is not 1. Okay, please ensure that you understand.